Okay, this is 5.2, the second part of the video. Now, we want to be able to make sense of our results. So, remember how we talked about unusual results? Our unusual results are outside of the parameters of our minimum and maximum values. Now, our minimum value is mu minus 2 times the standard deviations, or the mean minus 2 times the standard deviations. The maximum is the mean plus 2 standard deviations, as you can see up there. So let's go back to the birth of 2 girls. Let's say a couple has 2 girls out of the 2 births. Is this an unusually high number of girls? Okay, so let's first find out the minimum and the maximum. Okay, we know that the mean was 1. Remember solving that in the last part? And we know the standard deviation was 0.7. So, what we're going to do for a minimum, we're going to do 1 minus 2 times 0.7. 1 minus 2 times 0.7. 2 times 0.7 is 1.4. 1 minus 1.4 is negative 0.4. The maximum is going to be 1 plus 2 times 0.7. Again, this is similar. This is going to give me 1.4, but plus 1 is 2.4. So that means if my value is within negative 0.4 and 2.4, then we are not unusual, okay? We're pretty common. Now guys, there's no way to have a negative baby, and there's no way to have 2.4 babies out of 2. So truly, we're truly going in between 0 and 2, okay, as being normal. Well, since they had 2 babies and we're between 0 and 2, this is normal, okay? So it's not considered unusual. All right. Now, the rare events rule. Let's say we're looking at something being unusually high, okay? So, if you can hear my babies crying outside the door, sorry about that. This is when the probability is 0.05 or less. A short way of writing that is the probability that x is of x or more, okay, is less than or equal to 0.05. That's a shorthand way of writing what I explained here. And unusually low, this is when the probability of x, I should have put of x up there also, is 0.05 or less. The shorthand way of writing that is the probability of x or less is less than or equal to 0.05. In other words, if our probability is less than 0.05, then we know that we have an unusually high or unusually low event going on here, okay? So, before we talked about how there were, we brought this up, there were 879 girls born out of 945 births. Now this was with that birth selection thing that we had discussed before. So now we're going to go back to information. We're going to figure out how to solve this actually in the future here. But we're going to give you the probability as being 0 plus. Okay, the probability of this occurring is 0 plus, meaning it's basically a 0 chance of it happening, but there is a small possibility, so we can't just say it's 0, but it's 0 plus, okay? Now, since 0 is less than 0.05, we could say that this is an unusually high value, okay? It's unusually high. The reason why it's high is because 879 is a high number, right? We would expect, our expected value for this would be much less than 800. It'd be more in the 400 range. Okay, so now expected value in decision theory. Decision theory means our rationale, okay? So using expected value in helping us decide on what to do. Let's say you have $5 to place on a bet. I don't bet, so a lot of this is gonna, I can't really go into too profound details because I don't really know some of what's going on here, but you have narrowed your choice to one of two bets. You could bet on roulette, yeah, which means you bet on the number 7, or you're going to do craps, which means you bet on the pass line. I don't really know what that means. I'm sorry, guys. Anyway, our first question says the probability of losing at roulette is 37 out of 38. Okay? And the probability of getting a gain of $175. Now guys, the reason why it's a gain of $175, you win $80, but you paid $180, but you paid $5, so your net gain is $175. Okay, so that's what we're referring to here. That is a 1 in 38 chance. So, find your expected value of winning or losing at roulette. Well, okay, let's take losing. My X value would be, you lose, let's put here, X. You lose $5, right? So negative $5. Your probability of losing, probability of X, is 37 out of 38. And our expected value here would be this times that, right? So that answer is negative 4.868421. Okay, that's X times P of X. Remember, that's how we find expected value, which is your mean. All right, winning. That means you gain $175. That is a 1 in 38 chance. We're going to multiply X times P of X, and we get 4.605263. We add those together, and we get a negative 0.26 cents. In other words, your expected average is to lose 26 cents each time that you pay $5. So you're going to expect to lose an average of 26 cents. Alright, now let's look at the craps. With the craps, just remember this is negative 26 cents. I'll actually write that up in the corner up here so we can remember it. Okay. Now, craps. Your probability of losing is 251 over 495. And winning, your probability is 244 out of 495. Okay. You can, your earnings or your net would be $5. The reason is because you get $10 if you win and you paid $5, so you are really only getting a net of $5. Okay, what's your expected value? So we're going to do this again. If we lose, our X value is going to be negative $5 once again. And if we win, we only are going to get, I'm pretty sure I wrote this wrong, $5. Wrote it down wrong in my notes. So now we want to find the probability of these. This one was 251 over 495. And this one was 244 over 495. If we multiply this, we get negative $2 and 5353 so forth, okay? And we'll do 53 one more time. On this one, we would gain $2 and 464646. We add those together and we get negative 0.07 or negative 7 cents. You guys, there's a reason why the house always wins, right? If you were to choose which one of these would be worth your time the most, even though craps only wins you $5, your chances of loss is only 7 cents as opposed to 26 cents. So making an intelligent decision here on which one you should do, the craps would be a better choice in this case. Although the winnings for roulette would be bigger, you're losing more in the end. Okay, that's it for that lesson.